Great Calculus. We're on section 4.6, day 2. We're going to do composition and trig functions today, which means instead of just having, say, sine inverse of 1/2, we're now going to compose that with another function. So in this case, for A, sine of sine inverse of 1/2. Sometimes it might be cosine of sine inverse of 1/2. And we just have to take it step by step and think it through. So for this one here, I'm going to work inside my parentheses first. First, I'm going to figure out what is sine inverse of 1/2. Remember, sine inverse, we restrict our domain from negative pi over 2 to pi over 2. So somewhere in this piece of my unit circle, I want to know where is the y value, because it's sine. So where's the y value? 1/2. And because I've got my unit circle memorized, I know that's at pi over 6, which has this point here. And the y value is 1/2. So then I'm going to go, okay, well then what's sine of that pi over 6? And because it's sine and sine inverse, and we're in the first quadrant, sine of pi over 6 is just going to be that 1/2. So it spits it right back out. All right? Will it always be that easy? No, but if you see one, just grab it and run for it and be happy that you got a nice one. All right, B. We want to know what is, first, we want to find tangent of pi over 2. So pi over 2 is up here. That point is at 0, 1. So if I want tangent of pi over 2, remember tangent is y over x. Well, in this case, y over x is going to be 1 over 0. What's wrong with that? Uh-oh, we're dividing by 0. Is that possible? No. What's happening at pi over 2 on the tangent graph? We have an asymptote there. So if we have an asymptote, we're not going to have a value. I can't find the arctangent of pi over 2, even though it looks very similar to this. Gut instinct is just to put in pi over 2. But because we're not defined here, this whole thing does not exist. All right, and finally, we've got arcsine of sine of 7 pi over 4. So let's find 7 pi over 4. It's going to be here. Our point there is square root 2 over 2. Negative square root 2 over 2. We're in the fourth quadrant. All right, so what is my sine value here? It's negative square root 2 over 2. So arcsine of negative square root 2 over 2. Now you may be saying, well, it's arcsine at sine. Won't this just split 7 pi over 4 right back out? No, why not? Well, arcsine, we had to restrict that domain, right? It has to be between negative pi over 2 and pi over 2. We still want this angle, but we don't want 7 pi over 4 because that's not between negative pi over 2 and pi over 2. We want its coterminal angle, which is the whole reason why we found coterminal angles. So we're going to go this way with it, and that's going to be at negative pi over 4. That's got that value there for y. All right, go ahead and pause your video. See if you can do A, B, and C of the U. Try come back when you think you've got it. All right, A, tan inverse of tangent of pi over 3. This is one of those nice ones that is in the first quadrant. It's exactly what you think it would be. Here's pi over 3. Here's the values for it. Well, tangent of this guy would be square root 3 over 2 divided by 1/2, so it's just square root 3 over 1, or tan inverse is square root 3 over 1. Well, then when I go ask myself for which value, for what angle between negative pi over 2 and pi over 2, remember we restrict it to these guys, also for tangent, between negative pi over 2 and pi over 2, which angle would give me a tangent of square root 3 over 1? Well, that's this guy here that we just had. So, like I said, if it's in the first quadrant, you got tan inverse of tan, you can just spit that guy right back out, nice and easy. Does that work for cosine in the second quadrant? Well, let's investigate. Cosine of 3 pi over 4. 3 pi over 4 is here. That's at negative square root 2, positive square root 2. All right, so cosine of 3 pi over 4 is going to be negative square root 2 over 2. So then if I ask myself, Cosine inverse is negative square root 2 over 2 is like for what angle value is my x negative square root 2 over 2 between 0 and pi. It's going to be right back there at that same angle. So this is also just going to spit out that angle right back at us. All right, how about arc sine of sine 2 pi over 3? It worked for us for the first two. Isn't this just going to be 2 pi over 3? That's my guess. Seems to be the pattern, right? Hopefully you came up with something different. Let's do a little investigation. So sine of 2 pi over 3, that's up here. My sine value is square root 3 over 2. If I want to find arc sine of square root 3 over 2, be careful. Sine is restricted between which two angle measures? Between negative pi over 2 and pi over 2. So is 2 pi over 3 going to work for us? No, right? Because 2 pi over 3 is not between these two angle measures. So I need to ask myself, for what angle measure between negative pi over 2 and pi over 2 is my y value also square root 3 over 2? That's going to be at pi over 3. Because at pi over 3, this is my point. And that's where the y value is also positive square root 3 over 2. So it's going to be at positive pi over 3. My second thought was maybe it would be down here. But down here, my y value is negative. It's positive up here. So it's going to be at pi over 3. Come back and we're going to do some more of these more complex composition of functions in our next video.
Bye.